Hi, and welcome to my video on the pre-algebra section on multiples, divisibility rules, even and odd, prime composite numbers, finding the factor of a number, prime factorization, GCF, and LCM. And this is practice number 2. Again, we've broken up into 2 parts because of the length. So let's start. Circle the factors of 18. So the factors of 18 is those numbers which will divide into 18 without giving you a remainder. So 1 into 18. So 2 factors of any number. So automatically, if you say factors, you take 1 and that number, and you have a guaranteed set of factors. It ends in 8, so it's divisible as 2 is a factor. So 2 into 18 goes 9. So that means I have a 9. So 2 9s are 18. So 2 into 18 goes 9. 9 into 18 goes 2. Or the product of 2 and 9 is 18. 3. 3 into 18 goes 6. There's no remainder. So it's or. If you add up the digits, you get 9, which is a multiple of 3. So 3 is a factor. So 3 times 6, 6 is a factor. 6 into 18 goes 3. 3 into 18 goes 6. 4 is not a factor of 18. 5 is not a factor. 7 is not a factor. And 12 is not a factor. So those are the factors of 18. So any number that divides into a number that divides into another number, that number is a factor. Now list the factored pairs of each. Again, the factored pairs, the first ones I do is 1 times 12. First set. Now I notice that is even, so I see 2. So 2 into 12 goes 6. And I see a 3. Digits adds up to 3. So 3 is a factor. So 3 times 4 is 12. And that's all the factors. So we check the factors of 6. You get a 2. Right? So 2 again. Or you get a 3. So if you got a factor of 6, you automatically, if a 6 got a factor of 3, 12 is a factor of 3. So that's how I can go. 25. Again, 1 times 25 is a pair of factors. And it ends in a 5, so 5 is a factor. 5 into 25 goes 5. So 5 5s are 25. 33. Notice there's 2 3s, so it's, again, the first pair is 1 times 33. 3 is repeated, so it's 3 into 33 is 11. 11 is prime, so there's no more factor pairs. 42. 1 times 42 is the first one. I see a 2. So a 2 is, because it's a 2 ends, it's even. So 2 times 21. Now, the way that I do it, I see a 21. So when I see a 21, I think about a 3 times a 7. So that means if 21 has a 3, that means 42 has a 3. So if you think about it, if 21 has a 3, that means it must have 2 times 7, must be 14. So 3 into 42 is 14. And if 21 got a 7, that means that 42 got a 7. So check. So 2 times 3 times 7 is 21. So if you take a 7, you must have 2 and 3 left. So that must give you 16. And we have all the factored pairs. Check 6. The 6 got a 2 and a 3. 2 is here, 3 is here. So we have the factors. And 14 got a 7. The 7 is here. Now let's check the 90. 90 got a 1 and a 90, first pair. And I see it's even because it ends in 0. So it's 2 into 40, or 2 into 90 goes 45. Also, I see another one. I see a 10 because it ends in a 0. So 10 into 90 goes 9. It ends in a 0, so I see a 5. So a 5 into 90 goes 1, 6. 5 into 90, sorry, goes 1, 8, 18. Now, do I have them all? Well, I have a 8, I have a 10. A 10 has a 2 and a 5. There's the 2 and a 5, right? A 9 has a 3. I don't have a 3, so let's check with the 3. 3 into 90 goes 30. And I have a 30. Is there another factor? I see a 6. So 6 into 30 goes 15. And I got a 2, 10, 6. So I think I have them all by now. Factors of 30 is 15 and 2. There's the 2, there's the 15. And factors of 18 is a 3 and a 9. There's a 9, there's a 3. So that's all the factor pairs. Again, if you have a 45 as a factor of 90, then all the factors of 45 will also be factors of 90. Again, if you have a 10 as a factor of 90, then you'll have a 2 and a 5 as a factor of 90. If you have a 9 got a 3, so a 3 is a factor of 90, and etc. And it got 30, factor of 30 is 15, so you have 15 as a factor of 90. So that's the way that I find those factors, which is a really good way. Number 3, list all the factors of each in descending, normally I think about descending, but I want it in ascending. Descending means go down, ascending means go up. So what I do is I get all the factor pairs. So I get 1 times 18. 18 is even, so it's a 2 times a 9. And 18 has a 3, so it's a 3 times 6. And 9 got a 3, so 18 got a 3. Okay, now we have, I think, have all the factor pairs. Factors of 6 are 2 and 3, there they are, yep. So I have them all. So in ascending is 1, 2, 3, 6, 9, 18 are all the factors of 18. 45, factor pairs are 1 and 45. I see a 5, so it's 5 times 9. I see a 9 has a factor of 3, so 3 into 45 goes 15. 15 got a 3 and a 5. We have them all, I think. So we have a 1, a 3, a 5, a 9, 15, 45. So again, getting the factor pairs enables you to get all the factors of the number. And we have 80. So we have a 1 times 80. So an 80 has a 10. So let's go with a 2. 2 times 40. This is ends in 0. And let's see. I see a 10. So it's a 10 times 8. Ends in 0. I see a 5. So it's 5 times 16. Now, do we have any more? We got the 0 has a 10 and a 5. We have an 8. We got a 2. We have a 4. And 8 has a 4. So 80 has a 4. So 4 and 80 goes 20. And I have a 16 has a 2 and an 8 and a 4. I think that's all the factors. Sometimes you might miss one. So I see a 1, a 2, a 4, 5, 8, 16, 20, 40. 2, 4, 6, 8, 10. 2, 4, 6, 8. Now, okay, I have 2, 4, 5, 8, yeah, 16, 20, 40. So I got the 1, I got the 2, I got the 4, I got the 5, I have the 8, 16, yep, I have the 20, and I omitted the 10. I knew there was one missing here. So here's the 10 in ascending order, and it's the 80 on the end. So when you're trying to pick them all out, what you should do is start with and go through like this and then count them. You have 10 of them. 2, 4, 6, 2, 4, 6, 8, 10. Perfect. Now we got 99. Again, first is 1 and 99. 9 is repeated, so it's 9 times 9 to 99 goes 11. And 9 has a 3, so 3 into 99 goes 33. 33 got 11. Okay, yep. And I see it's not even, so it's 11, 33, 3 and 9. Okay, so 1, 3, 11, 33, 99. I got 1, okay, 1, 3, oh, see, left out the 9. 1, 3, 9. So there's the 99, there's the 11, there's the 33. Oh, I'm scratching out this one. And there's the 9, so I omitted the 9. Gotta be careful picking them up. Again, 2, 4, 6 factors. 2, that's a 9, 2, 4, 6. Number 4. Let's see what we can pick up with prime factorization. Find the prime factorization in ascending order. That means it will upwards, smallest to largest. Prime factorization is a multiplication such that all the factors are prime. So here we go. 10 is 2 times 5. So that's the prime factorization of 10. You got a 2 times a 5. Power is 1. 18. A couple of ways to do this. You can do this. You can go 2 times 9. And then you're going to make your 9 3 times 3. So that's 2 times 3 squared. So it's in ascending order. It's a 2 and a 3, but there's a power of 9 as a power, 3 as a power of 2 to make the 9. Another way to do that would be to take 18 and divide by 2 and with what they call a ladder. So 2 into 18 goes 9, and then a factor of 9 is 3, so 3 into 9 goes 3, and divide 3 into 3 goes 1. So now you got, because of the ladder, you got 2 and 2 3s, so there it is. That's two ways to do it. So I like either or, but so with 24, let's do several options with 24. What about if we pick 2 times 12? Well, 12 is 2 times 6. So that's 2 times 2 times 2 times 3. So that's 2 cubed times 3. What about if you picked 4 times 6? 4 is 2 times 2. 6 is 2 times 3. Again, 2 cubed times 3. So no matter what pair of factors you pick, other than 24, if they have them, it'll always work through. Or again, you can do the ladder. You can start with the 24 and divide by 2 because it's even, you get 12. It's even, so divide by 2 again, you get 6. Divide by 2 again, you get a 3. Divide by 3, you get a 1. So you got 2 times 2 times 2 times 3. And again, when I try to look at factors, I always start with a 2, then I look at a 3, and then I look at a 5. I always look at the prime. If it's even, keep dividing by 2. Try your primes. 36, I have 4 times 9. 4 is 2 times 2. 9 is 3 times 3. So that's the prime factorization of 36 is 2 squared times 3 squared. And again, if you want, you can do the ladder. It's even, divide by 2, you get 18. It's still even, divide by 2 and you get a 9. Factor of 9, 3 into 9 goes 3. 3 into 3 goes 1. So here's your prime factorization. 2 squared times 3 squared. Now let's look over the prime let's look at the GCF of each of these pairs of numbers. And see if I have the wrong. Ah, yes, I do. I had the pages in the wrong order. Sorry about that. Page 4 of 6, that's why I number my pages. Find the prime factorization of each in ascending order. So 54. 54 is 6 nines are 54, or you can say 6 times 9, or you could go 2 times 27. If you go 6 and 9, you go 2 times 3. 9 is 3 times 3, so it's 2 times 3 cubed. You could have gone with start dividing by 2 with the ladder. Then give you 27. Divide by 3, you get a 9. Divide by 3, you get a 3. Divide by 3, you get a 1. So you can either write the pair of factors and expand them, or you can do your choice. 75, I see 5 times 15. 15 is 3 times 5. So I see a 3 and I see a 5. 3 is 1. There's 2 5s. There's the prime factorization. Or you can do the ladder. Now, this is a bigger number. So if you want to do the ladder here, because it's even, go 2 into 126. That's 63. 63, you add up to 9, which is a multiple of 3. So 3 can go into 63, 21. 21 is divisible by 3. They add up to 3, so it'll give you 7. 7 into 7 goes 1. So you have a 2 times, so I have a 2, a 3, and a 7. But I have 2 3s. Excuse me. Now I have 360. 360, well, I would do 10 times 36. 10 is 2 times 5. 36 is 4 times 9. 2 times 2 for 4. 3 times 3. 2 cubed. 3 squared. And a 5. Excuse me. Apologize for that, but my throat was getting dry. Find the GCF. Now the greatest common factor. So to find the greatest common factor, what I do is I take the smallest number, take a factor of that number. So what factor of 10 is the factor of 18? So I see a 2. So 2 into 10 goes 5. 2 into 18 goes 9. And there's no more. So the GCF is 2 for 10 and 18. That's the greatest common factor. 9 and 12. Again, 3 is a factor of 9. Is a factor of 12. So 3 into 9 goes 3. 3 into 12 goes 4. There's no more. So the GCF of 9 and 12 is 3. That's the greatest common factor. Now what I do is I take 24 and 40, and I take the smallest number and put it first, because it's easier to get the factors of the smallest number. So what's the factors of 24 and 40? Well, I see a 2 is even. So divide and I get a 12, and I get a 20. Again, they're even, so I divide by 2, and I get a 6 and a 10. Again, I see that 2, they're even, so I divide by 2 again, I get a 3 and a 5. So the GCF is 2 times 2 times 2, so that's 2 cubed, so the GCF is 8. Using this ladder for GCF, if you can see 8 right away, remember, if you see 40 as 5 times 8, and you see 24 as 3 times 8, then 8 is your GCF if you can see those factors right away. But if you can't, you can use the ladder. So let's go here. Again, they're even, so divide by 2. I get a 7 and a 26. The GCF is 2 only. 7 is not a factor of 26. 45 and 30. Let's see, I see a 5 and a 0, so I see a 5 as a GCF. 5 into 45 is 9. 5 into 30 goes 6. I see a 6 and a 9, so a GCF is 3. 3 into 9 goes 3. 3 into 6 goes 2. So the GCF is 5 times 3, which is 15. So that's how I get the GCF of numbers. And there's more to do. Let's do more practice on the GCF. Now we got 3 numbers, but that doesn't make any difference. So let's go. Smallest number 6. Is 6 a factor of 24? Yes, not of 30. They're even, so let's divide by 2. I get a 3, 12, and 15. And is 3 a factor of 12? Yes, 15. So 3 into 3 goes once. 3 into 12 goes 4. 3 into 15 goes 5. So the GCF is 2 times 3 is 6. 6 is a factor of 6. 24 times 4 is 6. 5 times 6 is 30. So 6 is the GCF. And again, when I do these, I put the smallest number first, and then I put them in ascending order. So what factor of 50 gives you 75? I see a 5. So divide by 5. I get a 10. I get a 15. And I get a 20. And I see another 5. Factor of 10 as in 15 and 20 is a 5. So divide by 5 again. I get 2, 3, and 4. No common factors here. So the GCF 5 times 5, which is 25. And start with the smallest number, then the next, and then the next. Why the smallest? Because it's easier to find the factors of 18 than it is to find factors of 40. Not that bad, but the smallest number gives you the smaller factors. So what's the factors of 18? 18 is not a factor. What about 9? Yes, I see. You also see a 3, but I can see a 9. But if you said 3, they add up to 9, which is a multiple of 3. They add up to 9, which is a multiple of 3. So we went with 9 right away and did 2, 3, and 5. 9 is your GCF. Or you could have went with 3, but then you had to go with 3 again. And right here we have 14, 21, and 70. So is 14 a factor of 21? No. They're not. 14 is even, 70 is even, 21 is not. I see a 7. 7 into 14 is 2. 7 into 21 is 3. 7 into 70 is 10. So the GCF of those numbers is 7. And I see an 8, 28, and 44. Again, I start with the lowest first. Now, they're even, so I'll divide by 2. Because it's a 4, 8, and 8 is even. So that's a 4, 14, 22. Again, they're even. So divide by 2, I see a 2, a 7, and 11. So the GCF, there's a 2 here, 7, no GCF. So 2 times 2 is 4. So that's a review of finding the greatest common factor, which is extremely important when we do factoring in algebra, at the end of algebra 1 and then algebra 2 and then all calculus, everything. Very important. We always find the GCF when we go to factor. Do the GCF first. Now, what about finding the LCM as a letter? The LCM is the least common multiple. So one way to get the least common multiple is, notice there's a 2 and a 3 here. So the least common multiple for 2 and 3 is their product of 2 times 3, which is 6. There's nothing common, so the least common multiple is their product. If there is something common, like here we have a 2, so let's use the ladder method. So one way is 2 is a GCF, so greatest common factor, so we divide, get 2 and 5. Now, we don't have, but if you're doing the LCM, you keep going. If you're doing the GCF, you stop, because 2 is the only number to divide into these That's the factor. So divide by 2, you get a 1, and it won't go into 5. Now, what's left over? We got a 5. 1. So the LCM is 2 times 2 times 5. 4 times 5 is 20. So the least common multiple of 4 and 10 is 20. In other words, 4 times 5 is 20, 10 times 2 is 20, 20 is the smallest multiple of 4 and 10. And this is a way to do it, by the ladder method. You keep going until you get all ones. So 2 and the 5 can't go, just leave the 5 there. If it doesn't divide into it as a factor, just bring it down. And we got a smallest number first, so let's go with the ladder. So 2 is a factor, they're all even. So I get a 3, a 4, and a 6. Now, as long as there, you can pick any factor here. You can take the 3 if you want. 3 into 3 goes once, 3 won't go into 4, 3 into 6 goes 2. Now I see a 2. 2 into 4 is 2, 2 into 2 is 1. Remember, if it don't go, just write the 1, write it down. And what do I see left? I see a 2. There's a 1, 1, 1. So I get 2 times 3 times 2 times 2. So that's 2 times 2 times 2 times 3. 8 times 3 is 24. So the LCM is 24. Least common multiple. There's a larger multiple, but the least one. So 4 6s are 24. 3 8s are 24. 2 12s are 24. So let's look at 9, 14, and 21. Again, let's do the ladder. Take any factor of these numbers and divide into it. You could take 7 if you want. You could take, you take a 3. 9 won't do it. So let's take the 3. 3 into 9 goes 3. It won't go into the 14, and it goes into 21 7. Now, what do I see? I see a 3. I got a 3 first. So 3 into 3 goes once. Won't go into 14, won't go into 7. And I see a 2. Won't go into 1. 14. 2 into 14 is 7. Won't go into 7. We divide again. And I see a 7. 7 won't go into 1. 7 goes into 7 once. 7 goes into 7 once. So what we have is the LCM is, I have a 2. I have 2 3s, which is 3 squared. Or I can write down 2 3s. And I have a 7. So that's 6, 18, and 18 times 21. Well, just do a little bit of multiplication here. 8, 378. I didn't have the answer worked out, but, or I could go, let's check it. I could get a 6 and a 21. 6. Oh, look at the error I made. That's a 6, and that's a 21. So 6 times 21 is 126. So I check myself. So where did I get 18? I don't know where I get 18. It's supposed to be 6. I multiplied these two and got 18. But it's supposed to be 18 times 7. So I check myself. Again, that's a 6, that's a 21. When you multiply, you get 126. So I checked myself, that which was good. Sometimes if you're checking, make sure you do it right. Now, find the LCM of each. This time we're going to use the prime factorization. On the other page, we use the ladder. I like the prime factorization and I like the ladder. But the prime factorization comes back later on in the math topics we're going to do in Algebra 2, etc., etc. So, prime factorization. Let's look at the 9. The prime factorization of 9 is 3 times 3, which is 3 squared. 21 is 3 times 7. So when you're doing prime factorization, you write down each factor. So you have a 3 and a 7. So here you have 3 squared, so you take the largest one. So 3 squared and a 3, 3 squared. And so you get 9 times 7. So the LCM, 9 times 7 is 63. Prime factorization. You write it, prime factorization down. You pick one of each of the factors. So if you got a factor, whatever factors you have, you write them down, and you pick the highest power. 8 is 2 times 4, which is 2 times 2 times 2. 8 is 2 cubed. 20 is 2 times 10. 10 is 2 times 5. So that's 2 squared times 5. So I have a 2 and I have a 5. The highest power of 2 is 3, and there's only one 5. So it's 8 times 5, 40. So the LCM is 40. So 5/8 is 40. 2 times 20 makes 40. So the least common multiple for 8, 20. Again, I repeat, you can do the ladder method or you can do the prime factorization. Your choice. 6 is 2 times 3. 18 is 2 times 9, which is 2 times 3 times 3. That's 2 times 3 squared. 24 is 4 times 6, 2 times 2. For 4, 6 is 2 times 3. So that's 2 cubed times 3. So I have a 2 and a 3. So it has a factor of 2 and a factor of 3. So the highest power of 2 is a 3. The highest power of 3 is a 2. So that's 8 times 9, 72. So the LCM, least common multiple, for 6, 18, and 24 is 72. Again, prime factorization. Or you can do the ladder. Now, I got a 10, I have a 25, and I have a 35. So the prime factorization of 10 is 2 times 5. 25 is 5 times 5, which is 5 squared. 35 is 5 times 7. So I have a 2, I have a 5, and I have a 7. In relation to 2, there's only one of them. There's 2 5s, and there's 1 7. So if you want to work this out, what I do, I watch how I multiply this. I go 2 times 5 times 5 times 7. I make this a 10, and that's a 35. So I go, anytime I multiply numbers to get a 10, it's easy because when you multiply by 10, you just get the 0 added on. So that's, so the LCM. But I just want to, again, show you the ladder on that. So you got a 10, 10, 25, and 35. So you're doing the ladder. I see 5 as a factor. So it's 2, 5, 7. Notice now, there's nothing common there. So keep dividing. 2 into that goes 1, right down to 5 and 7. 1, 1, 7. 7, 1, 1, 1. So you get 5, 2, 5, 7. So you get 1, 2, 2 5s, and a 7. There they are there. So again, you can do prime factorization and write down each factor and pick out the large exponents and expand it to get the LCM, or you can do the ladder. The ladder, again, if you remember the ladder to do, ladder is good because the ladder, if it's GCF with the ladder, once it's not a factor, then the GCF is right here. If it's not LCM, you just keep going until you get all ones. So that brings us to the end of this video. And again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, the content, and my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye. Just wanted to say I apologize for the little sport of coughing that I had there. Goodbye.